Um, so earlier I mentioned that artificial neural network has been studied for a long, long time, at least 25 years since the first time that I heard about it. But it didn't make a big splash until recently. The major issues earlier is when we propagate the arrow back to the network in the backward way. So remember, when we train, when uh, we have a forward process to push the data from the beginning layer to the output layer to get output. When we computed the arrow, we need to propagate that arrow back to update the weight of every layer. This arrow distribution involves the product of multiple layers. So the layer at the very beginning of the network could be very big or very small, because when you take the product of many small numbers, you're going to get extremely small number. That makes the learning rate really, really slow. So the weights at the beginning of the layer almost not updating itself every time a training example passed through. In some other situations, you could have bigger numbers, greater than 1 numbers. When you have lots of those numbers, product of those numbers, you're going to have a very large learning rate, effective learning rate at the beginning of the network. That will make, remember our graph there, you could actually certainly jump over and miss certain important things. So the rate of learning, therefore, are different in different layers. And we know the earlier layer learns the basic features, that later layer use the basic features learned from the beginning of the neural network and construct more abstract and more useful features. If the learning rate are not consistent, then it certainly hurts the performance of the algorithm, the entire system. It take a very, very long time to train, and it does not provide a very good result. Over time, people have researched different network topology, and there are studies, as I mentioned before, lots of studies on how to initialize the weight for the network to reduce the chance of unstable gradient problem. And the activation functions right now, I think ReLU is probably the popular one, or the leak ReLU, because it has a tendency to reduce unstable gradient problem. Design issues, really there's not much to say, because a lot of those hyperparameters you have to just to try out given your problem. There's typically, if you do image processing, I mean, it's definitely convolution network. If you do other type of analysis, they're probably also well-known and tested neural network topologies, and you should start with those. And then adjusting the hyperparameter, as we have demonstrated and stated before, you can use grid search or random search to find a good combination of different parameters. To summarize, artificial neural network is really, they're universal approximators that could suffer overfitting. For interpretability, I think we also talked about this. Gradient descent, because the objective function is not convex, it could converge to local minimum. You could, by random training examples and run thousands of epochs, with validation might help address this question, but there is no guarantee that you will find the global maximum. And it's not known to you whether you'll find or not find global maximum. You often need a large amount of training example. And even with large amount of training examples, you do that you do many epoch, so it's very time consuming. Yeah, so next point I mentioned, the building model is very time consuming, but testing is very fast and the performance are often good. So I guess to some extent, it's worth the time to build the model. It learns the feature along the way, unlike other algorithms that we have to provide the feature. If the wrong feature being provided, the system will just not perform. Work well with unseen data. Well, whether something work well with unseen data is really just a matter of a degree. Many about portability or robustness of this learning algorithms are still a very active and open research area that nobody seems to have a very good idea on how to handle. This is also one of the reasons unsupervised methods sometimes would claim that we don't need any training examples and our performance is not so bad, so why don't we just do unsupervised learning? Okay, I'm going to stop here and ask you for questions.
Yeah, I don't know if that's too far, but what is the difference between the recurrent network and the back propagation of the error?
Good question. Back propagation is actually used to update the weights in any neural network.
Yeah. Ah, okay.
Recurrent network means that it changed the feed forward network. Your input are not just going from layer 1 to layer 10. You actually have circles. So your input go to layer 2, go to layer 3, come back to layer 2, go to 3, come back to 2.
Okay, thank you.
Yeah, this allows you to memorize some of the things. If you have sequence or dependencies among your input, the recurrent network allows the network to record those information and make use of it.